Okay, I'm back. I literally took just a second to start uploading the first video. I'm sorry it took so long. Uh, that's a that's a tough pill to swallow, but I'm gonna go ahead and start the FRQ section, and then I'll have another video on the grading portion, and you can watch that. It's up to you. You don't really have to comment on it. But anyway, here we go. So this is a graphing calculator problem. Awesome. My graphing calculator stinks right now, but anyway. Here we go. Grass clippings are placed in a bin where they decompose. For time 0 to 30, the amount of grass clippings remaining in the bin, that's a good, not going, but remaining, is modeled by that, okay? And that's the amount. It's not the acceleration, it's the amount, okay? Where A of t is measured in pounds, so there's our units, and t is measured in days, okay? So we're ready to go. We got it all highlighted up. Oh, let me blow it up for you. Okay. Zooming in. We got it all highlighted up, ready to go. Okay, find the average rate of change. Oh, that's easy. We'll have an integral on it. 0 to 30. Oh, 1, 30 minus 0, 0 to 30, 6.687, 0.931 t dt equals average value. You must write the 1 over 30 right here. Must continue to write that, okay? 0 to 30. Alright, well, anyway, let's go ahead and integrate that using our calculator. Okay, which means I have to get off of this. I'm going to pause every time I use the stinking calculator because it takes so long. Alright, I'm back. I got it in my calculator, so let's go. Average valued up. We're going from 0 to 30. Double check my interval. Yep. So, second quit. Alright, math 9. 0 to 30. Bars, function. Oh man, bars, function. Y sub 1 with respect to x. Boom. Alright, so that's, remember you gotta write all 10 digits, okay? 80.579, 82, divided by 30. Oh man, I hate that. Alright, so 2.753. Okay, so there you go. Cool. So that's the average value. And now you got to explain it. See, indicate your units of measure. So what are we taking the average value of? Okay, we're actually finding the average value of, let me move this out of the way. We're actually finding the average value of, A of t is measured in pounds. So we're finding the average value of this function. And this function is in pounds. So my average value of this function is pounds. So 2.753 is measured in pounds. By the way, I am timing myself. We're now 8 minutes into this transmission here, but I kind of I've been slacking the first 8 minutes, but we'll catch up. We got 30 minutes to do these two problems. All right, B. Find the value of A prime and 15 using correct units. Interpret the meaning of the value in the context of the problem. A prime 15. Well, calculator. I'll probably go over because this calculator is so slow. That should be pretty easy though. Math 8, DDX, bars, dang it, bars, okay, and we're 15, yeah, okay. Alright, so negative 1.64, negative 0.164. What's this? This is pounds per day. Okay. Oops. And I could also elaborate pounds remaining in the bin. It's probably worth a point. You probably remaining in the bin. Now you'll be given a booklet with tests, so I'm cramped with room, so I kind of have to improvise. So I'm sorry about that. But yeah, it's the pounds remaining in the bin per day. Wait, no, I just had a brain fart. That's the derivative. So that's the. I just had a huge brain fart. Okay, this means the pounds remaining in the bin decrease at a rate of negative 0.164 pounds per day. But that's wrong, because you got to also say at, on, or at, or on day 15. You got to be very specific. Okay, very specific. Okay. All right, so we're gonna. I need more paper. I didn't think I would need more paper. Okay. I'm gonna write on the back of another one. All right, so A, B. Moving on to C. From the time T, find the time T for which the amount of grass clippings in the bin is equal to the average amount of glass clippings in the bin over the interval of 0 to 30. So basically, I want to find out when this is equal to the answer I had before. So the function is equal to the answer I had before. So basically, when does 6.687 times all that equal, where did I get 2.753? Okay. So basically, what I'm trying to find is when A of t equals, what was my answer? 2.753. Okay, so what I'm going to do here is a cool little trick. Alright, using the calculator. I'm going to set them equal, alright. I'm going to make a totally different equation, or a totally different function. I'm going to make that function equal to 2.753. Okay, and I'm going to see where the two functions intersect. Wow, what a big concept. So, so I'm going to graph it on 0 to 30, so being careful, I'm going to do my window x min 0, x max 30. Graph. Okay. Alright, so right there, so second calculate, second trace, intersect. So close yet so far away. First curve, second curve. Now I gotta guess, get closer. So 12.41413 at t equals 12.413 days. Okay, so that was the answer for C, which was find the time the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin over the interval 0 to 30. D for t is greater than or equal to 30. LT, the linear approximation to A at t equals 30, is a better model for the amount of grass clippings remaining in the bin. Use LT to predict the time for which there will be a 0.5 pound of grass clippings remaining in the bin. Well, that's pretty simple, but it's a lot because we want a linear approximation, which is a tangent line. Okay, that's all it is. So we got to find the tangent line at t equals 30. What does that mean? Okay, that means D I'm zoomed in too much, I think. Okay, there we go, that's much better. Okay, y minus y1 equals m times x minus x1. I already know x is 30. I need to find my slope, so that's gonna be the math 8, because it's gonna take the derivative and take the slope for me. So math 8. Oh goodness, I was supposed to quit first. Math 8. Math 8. Okay, that's x bars over function y sub 1. Well, this is working pretty good for this size. I should have kept it at this size the whole time. So my slope is negative 0.055976 to 123 x minus 30. I have no idea if you're supposed to write all 10 digits or not. I guess so. That's cruel and unusual. So y minus y1, I got to find the y, so I'm actually just going to go to the original function here. Alright, I'm going to go to the original function. I'm going to calculate value at 30 is 0.729. It's 0.729. I have no idea if I need to write all that. I'm just going to go ahead and do it. 7829278 negative 0.0559762123 x minus 30. Okay, so now here's, I have all this written down, and now I need to approximate. I need to find out when it's equal to a half pound of grass clippings. Okay, so let's look at the question again. I want to find out when it's equal to a half pound, 0.5 pound of grass clippings remaining in the bin right there. So what do? Well, I just set it equal to 0.5. And instead of setting it equal to, since I have this big monstrosity of an equation, I'm just going to make y 0.5. Okay, so now is where the calculator becomes king. Okay, so right here, so 0.5, oh, quit, 0.5 minus 0.728292787, enter. I'm going to divide that by negative 0.0559762173, enter, and I'm going to add 30. Just solve them backwards. 34.0798. Alright, so let's write it in terms of what it wanted us to write it in, which is basically, okay. Well, let's just write it out in a sentence, okay? At time equals 34.078 days, the amount of grass clippings will be 0.5 pounds. Woohoo! That was a long one, and yeah, it just took a long time. It took me about 15 minutes, which basically I'm doing a lot of explaining here, so don't get too scared about it. Alright, number 2, where'd number 2 go? Number 2, here we go. Alright, here we go. So, let's blow this up. Well, we got to balance between. Let's do full screen. See if we can do full screen. Nope. Alright, so let R be the region of that, and the horizontal line y equals 4. Find the volume of solid generated when R is rotated about the horizontal line y equals -2. Okay, so that's 4, and -2 is way down here. Okay, so that region basically is going to be all this rotated in a big old circle. Okay, so basically your small radius is going to be the function f of x minus -2. That's your little radius of this little, and your big radius is going to be 4 minus -2. This big one, 4 minus -2, and there you go. So your volume is going to equal integral pi integral, this is for A, pi integral, the integral from, well, they didn't give us our intersection points either, so we've now we've got to graph this in our calculator. Holy smokes. So this is a lot here. So here we go. So y equals, clear. I wish I brought my calculator home. I'm just dreading it now. X to the 4th power minus 2. Well, actually, if you just look at those, we can do this algebraically faster. Set them equal to each other. That means x to the 4th minus 2.3 x cubed. X to the 4th minus 2.3 x cubed equals 0. Oh, you can't see any of it, I'm sorry. Basically, if you set them equal to each other, now you've got 4 equal to x to the 4th power minus 2.3 x to the 3rd plus 4. So 0 equals x to the 4th power minus 2.3 x cubed. So 0 equals x cubed, parentheses x minus 2.3. So x equals 0 and x equals 2.3 are your intersection points. There you go. Don't use the calculator, but you still need to plug them in to find the volume. Okay. So, well, we have our intersection points of 0 to 2.3. The big radius was the 6 squared. Take away 0 to 2.3. Small radius was f of x minus 2, so plus 2 squared. Don't forget about your dx. And that's all I have to write. The rest is in the calculator, so here we go. X to the 4th power minus, so x caret 4 minus 2.3. Oh boy. Minus 2.3 x caret 3 plus 4. Alright, so I'm going to do it a little bit different. Yeah, I'm just going to do it by the book. So, math 9, 0, 2.3. And then I know that's going to be 6. Or I could just put 6 squared, so it's 36 dx. Take away math 9, 0, 2.3 bars, y sub 1 plus 2. Or I could just, change it from the beginning. So, oh, you know what I forgot? I forgot to square it. So, parentheses, second insert, parentheses, squared. And I didn't do this in terms of pi, so basically it's 31.47 pi, 471 pi. So, alright, so this, the volume is going to equal, what do we say, 31.471 pi units cubed. Alright, so, hooray for slow calculators. The region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is an isosceles right triangle with a leg in R. Okay, so I'll go over this. Alright, with a leg in R. Find the volume of this solid. So each cross-section perpendicular to x-axis is an isosceles right triangle with a leg in R. So if it's isosceles, that basically, let's take a look here. I'm going to blow this up. Alright, so we didn't have the time to talk about volumes of solids with known cross sections, so here we go right now. Basically, if it's an isosceles right triangle protruding out of R, it's going to be basically millions and trillions of these isosceles right triangles, right? And it's going to create cross sections of isosceles right triangles. All your job is to do is to find out what is, and yes, it's a triangle coming out of an area. Your job is to figure out what the formula is you need to integrate. So, I mean, it's that simple. B, how do you find volume? Integrate area. What's the area formula for a triangle? 1/2 pi, or no, 1/2 base times height. Okay, luckily here the base and the height are the same, so it becomes basically 1/2 like base squared. Okay, what's the base? What is this distance? What is this base? Let's look at it. Base equals what? It's basically this y value minus that. It's top minus bottom, y'all. It's top minus bottom. Okay, so volume is equal to the 1/2 the integral again from 0 to 2.3. The top function which is 4 minus the bottom function which is x fourth. Well, basically those 4's are going to cancel out, so I could just write it as, no I can't. Volume is equal to 1/2 0 to 2.3. 4 minus x to the 4th power minus 2.3 x to the 3rd power plus 4 squared dx. Okay, so I'm going to rewrite that a little bit nicer. 1/2 the integral of 0 to 2.3. Those are basically going to cancel, and you're going to get negative x to the 4th power plus 2.3 x to the 3rd power squared. Okay, so we need to integrate that. We're going to use our trusty dusty slower than Christmas absolutely useless calculator. 0 to 2.3 bars. That's where I need some more caffeine again. Y sub 1. No, I'm not using y sub 1. What am I doing? Where am I going? Okay. Anybody? Let's just type it in. Negative x to the 4th power. Oh my gosh. To the 4th power plus 2.3 x to the 3rd power so I forgot to square it. Okay, so I've got to go all the way back. Insert parentheses. This is horrible. Torturing myself here with this calculator. Not that this problem's bad, it's the absolute sheer length of time it takes to use this calculator app. But it's my fault. So it's 7.147, and I'm going to take half of that. Okay, 3.5. So the volume, switch over here. The volume is now going to equal whatever that said. 3.574 units cubed. Okay? Alright, so let's go ahead and finish up. See, the vertical line x equals k divides r into two regions with equal areas. Write but do not solve an equation involving integral expressions whose solution gives the value of k. Well, that's just crazy talk. Okay? Basically, you want two integrals giving area equal. Okay? And where's k? K's in between them, so k is going to intersect. Wait a second. The vertical. Okay, so k's in between them, and k is going to determine, instead of your a and b, k is going to be like your intermediary point. Basically, you got something like this. There's r, you got k. So instead of this being 0, 2.3, now you got a k, and they need to be equal. We'll just do an integral and set them equal to each other. So let's go ahead and set it up. Okay, so c. Whew. Alright, so c, integrate from 0 to 2.3. The top minus bottom again, so still the function 4 is on top, that's on bottom. So 4 take away f of x. I'm not going to write the whole thing. Dx. Alright, no, it's not 0. See, I already messed up again. Alright, 0 to k. 4 take away f of x dx is equal to integral from 0 to, see, I messed up again. Integral 0 to k, 4 minus f of x dx equals, okay, from k to 2.3, 4 minus f of x dx. Boom, that's it. Non-calculator portion over. That took me a long time. So most of it was due to the calculator though. And the fact that, hey, it takes a long time sometimes. Alright, so I'm going to move on to the non-calculator portion right now. Thank the Lord. Yeah. That was supposed to be 30 minutes, and I pretty much took all of 30 minutes. I've basically been working and videoing and setting up stuff for an hour 53. That's a total work time of about an hour and a half, okay, that I've been working thus far, and I'm almost complete. You guys have a total of work time of 3 hours, okay? So, 153, let's get started on the non-calculator portion. If you have an hour on this, I'm going to try to do it in half an hour or less, okay? So, the function f, thank God we don't have a calculator. You have to use a calculator. Function f is defined by, on the closed interval, -5 to 4. Okay, the graph f consists of 3 line segments and is shown in the figure above. Let g be the function defined by g of x equals -3 to x f of t dt. Basically, what that's saying is you start at -3, and g of x is basically the area under f from -3 to x. Okay. All right. So find g of 3. So what I'm going to do here is I'm going to say, all right, that's 3. So g of 3 is going to be the area under f from -3 to 3. So basically it's non-calculator, so we got two triangles, so it's going to equal 1/2 base, which is 3, height, which is 4, plus 1/2 base, which is 2, height, which is 4, minus that 1/2 base times height. That's basically 1 minus 1. So that's half of 12, which is 6, plus half of 8, which is 4, minus 1. So basically, for A, I can put g of 3 equals 9. On what open interval is contained in there is the graph of both increasing and concave down. Okay, so we're looking at area now. So increasing and concave down. So we have to use a little bit of basically we have to use a little bit of antiderivative knowledge. If g is the integral of f, that means f is the derivative. So if f is positive, we're increasing, okay? And if f is also increasing, we're concave up. Okay, so if the derivative is positive, increasing. If f prime of x is increasing, concave up. And this is speaking about the original function. So I see positive and increasing here, and that's it. So basically on the interval -3 to 0, g is increasing, and concave down. Okay, so that scratches it. That would be this one right here. On 0 to 2, g is increasing and concave down because on 0 to 2, f of t is greater than 0, it's positive, and f prime of t is less than 0, or the slope of f prime of t is negative. Yeah, and that's pretty much it. You can say it a couple different ways and be alright. So B, let's move on to C. Function h defined by h of x equals g of x divided by 5x, find h prime of 3. So h prime of 3 is going to equal, first let's find h of x. H of x is going to be equal to this is a quotient rule, yeah? So it's basically derivative of the top, g prime of x times the bottom, 5x, plus the derivative of the bottom, 5, times the top, g of x, all over the bottom squared, so 25x squared. Okay, so the derivative of the top is, alright, so now h prime of 3 is going to be g prime of 3 times 15 plus 5 times g of 3 all over 25 times 9, which is 25 times 9 is 225. Okay, so now we just got to find g prime of 3 and g of 3. So g of 3 we already found, it's 9. So 9. Then we got to find g prime of 3. So g prime of 3 is basically just f of 3, yeah? So whatever f of 3 is. So f of 3, if we look at our graph, because g prime of 3 is basically the derivative of the integral, so they kind of cancel out. So f of 3 is -2. Okay, so right here, -2. Okay, h prime of 3 equals -2 times 15 plus 5 times 9 over 225. So h prime of 3 equals -30 plus 45, which is 15 over 225. You can leave it like that, but I'm a Nazi, so I'll simplify. So that's 3 over, dang it, oh, wait, that simplifies completely. 225 divided by 15. You know what, I'm just going to leave it. 15 over 225 is good to go. Okay, so D, function P is defined by P of x equals, alright, we're going to put this on hold. phone call that I have to answer. And we're back. Sorry, I had to answer that. And I'm not sorry I had to answer it. But all right. So now we're on to D. Okay. So the function p is defined by p equals all that f x squared minus x. Basically, you need to plug x in x squared minus x, then plug it into p. Find the slope of the line tangent to graph p at the point where x equals 1. Oh my gosh, so that's a chain rule, okay? So basically, so you want to find, I need another sheet of paper. Okay, so if p of x is equal to f of x squared minus x, then p prime of x is equal to f prime of x squared minus x times the derivative of the inside, okay, alright, times the derivative of the inside, which is 2x minus 1, okay? So my brain might be going to mush here, but I'm pretty sure this is on point. Yeah, it's basically a chain rule, okay? So y minus y1 equals m times x minus x1. Our x is negative 1, so plus 1. We need to plug x into this derivative in order to find the slope. So p prime of negative 1 equals f prime of negative 1 squared minus x, so negative 1 squared is 1 minus, so it becomes 1 plus 1, and that's also times 2 times negative 1, it's negative 2 minus 1 is negative 3. Alright, so p prime of negative 1 equals f prime of 2 times negative 3, f prime of 2, oh my gosh, f prime of 2, which is basically the slope of the tangent line at 2. Let's go back up here. Here's 2. What's the slope? 1, 2, 3, 4, 1, 2. So down 4 over 2, which is negative 1/2. When you simplify it, no, negative 2. So it was down 4 over 2, which is negative 2 over 1, which is negative 2. So p prime of negative 1 equals negative 2 times negative 3, which would be 6. Yay! And so y minus y1. Now we got to find the y. How do we find the y of this function? Well, we're given the equation. We're going to plug in negative 1 here. P of negative 1 is equal to f of negative 1 plus 1. So f of 1 plus 1. So p of negative 1 equals f of 1 plus 1, which is f of 2. Stop, phone. F of 2. Okay, so f of 2 is the actual y value at 2, which is 0. So p of negative 1 equals 0. Alright, so go back to the problem. P of negative 1 is 0, so bada bing, bada boom. Y equals 6 times x plus 1, and I ain't doing nothing else with that. Wow. Okay, so we're on to the next one. We're in a crazy race against time. Okay? Looking for number 4. Good. Train A runs back and forth on east-west section of railroad track. Change A velocity measured in meters per minute given by differential function. What t is time in minutes? Talks about find the average acceleration of train A. Okay, over the interval 2. Oh man, see. All right. Well, look. Here's the deal. Basically, a slope. Okay. You know, average rate of change is a slope formula of the position function. Remember that? Okay. Average acceleration is a slope formula of the velocity function. So you take this slope formula from 2 to 8. It's the slope formula of the velocity function from 2 to 8 here. Because we got 2 and 8. Average acceleration, same thing as average rate of change. Okay. So 2 to 8. It's 220 divided by 6. I don't know. negative 110 over 3 average acceleration on 2 to 8 time is negative 110 over 3. Okay, so very good, I think. Alright, B. Do the data in the table support the conclusion the train's A velocity is negative 100 meters per minute at some time with 5 to 8. Okay. Okay. So, alright, it's continuous and differentiable. It has to go. It goes from 40 to negative 120, so it has to cross negative 110. It doesn't make any sense for it not to. Alright, but it says to give a reason for your answer. So now we're gonna play around with some basically number speak, okay, which is the IVT, the intermediate value theorem. So given that given C, where C is greater than 5 and less than 8, and given f of 5 equals 40 and f of 8 equals negative 120, by the IVT, the intermediate value theorem basically states that if the x is between two x's and is continuous and differentiable, then it's subsequently the y must be between the two other y's. That's it. So this C, they're talking about being between 5 and 8. Obviously, negative 110 needs to be between, yeah. So what we state it this way, saying first that the C is between the two x's, and then secondly, stating the two y's. Okay? There must exist some f of C equals negative 110 okay, there must exist some f of C, oh that's a negative 100, sorry, negative 100, okay, where so basically now we can state that this f of C is going to be between 40 and negative 120, and well, that's pretty much it. We've stated the two things: the x is between the two x's, and the y is between the two y's. So this must exist. Okay, and IVT is weird. Usually you don't get questions on the AP exam that ask you to do an IVT, but this one does. All right, C. At time t equals 2, the train's A position is 300 meters. 300 meters east of the origin station, and the train is moving to the east. Writing expression involves an integral to get the position of the train A and meters from the origin. So time equals 2, 300 meters east, east, west. Which way would be east? East would be in the positive direction. The train is moving to the east, so it's increasing further. Writing expression involving integral to the position of the train A and meters from the origin station times t equals 12. So okay, so we want to use an integral to find out where this train is. So basically, that would be the position at 2, 300, plus the distance traveled from time 2 to 12, okay, of the velocity v of t dt, and that's going to give basically the position at 12, okay? Alright, so we can say that equals P of 12, alright? Equals. Alright, So then that's going to be approximated by the summation, the trapezoidal sum of 3 subintervals indicated by the table to use position to find the position time t equals 12. So 3 subintervals is funny because I see, hold on, 1, 2, 3, 4 opportunities. But since they say 3 subintervals, that basically means 12 divided by 3 is 4. So there's not a 4, there's an 8. There's basically between 2 and 5. So basically you're stuck with guessing, alright, which one's better? Which one do I mark out? Do I mark out this one? Well, 4 would be closer to the 5 than it would the 2. So we're going to mark out the 2. Okay, so we're going to do these 3. Okay, and so basically now, I wish I could show you the whole problem. I can. Okay. Alright, so I equals 1, 3. Alright, so it's 1/2 v of t minus I minus 1 plus v of t I minus 2, no, t of I times delta t equals, so we just got to add up our 3 trapezoids, 1/2 base 1, which is 0, plus base 2, which is 40, and the delta t there is 5 plus 1/2, base 1 is 40, plus negative 120 times the change, which is 3 right there, plus 1/2 negative 120 plus negative 150 times the height, which is 4 there. Okay. So basically, non-calculator, this is not that bad. So 40, half of 40 is 20 times 5 is 100. So that's 100. Half of that adds up to being negative 80. Half of negative 80 is negative 40 times 3 is negative 120. And then right here, that's half of 4 is 2. That's negative 270. 270 times 2 is negative 540. Okay. Alright, so adding that up, that cancels, makes negative 20. Negative 20 plus 540. Moving on to the back of another sheet of paper. Alright, so that's negative 20 plus negative 540 is negative 560. And basically, so basically this thing swings back to the left really hard. And basically, I should have added in here 300 plus all that. I am so sorry. That would have been wrong. They would have not, I guarantee they would have dinged me a point right there. So it's basically 300 minus 560, which is negative 260. Alright, so this basically the position at time equals 12 is approximately negative 260. Okay? The second train, B, travels north from the origin station at time t, the velocity of train B is given by v of t negative blah blah blah. Time 2 train is 400 meters north of the station. Alright, find the rate in meters per minute at which the distance between time A oh my gosh, this is crazy. The distance between train A and train B is changing in time equal to, this is related rates. Okay, holy cow, the AP exam has gotten a little bit harder since my day, I think. So 400 meters north of the station, so we've got 400. Actually this is negative 260, so no, it's time t equals 2, so yeah, so at time t equals 2 it said it was 300. Okay, and so and times t equals 2 the velocity of this train, so let's do since this is going east, let's do dE dt. Okay, let's name that east train and north train. dE dt equals 100. Okay, And then at time t equals 2, we got to find how fast this train is moving, dn dt. And my timer just died. My phone couldn't hang with me. dn dt, so dn dt is based off of the velocity of the northbound train, which is this. So I got to plug in 2 to that. So negative 5 times 2 squared is 4. 4 times 5, negative 5 is negative 20. And 2 times 60 is 120. I got to write this down. So velocity at time equals 2 of the northbound train is modeled by negative 5 times 4, which is negative 20, plus 120 plus 25. So v of 2 equals 125, basically. Okay? And that's, if you remember the equation, you see it right there. And that's where I got this. So v of 2 equals 125, dn dt equals 125. And if you remember, you can use, let's call that c. So we want to find dc dt. We want to find out how fast the distance between train A and train B is changing at time equals 2. So dc dt. So we're going to use the Pythagorean theorem, a squared plus b squared equals c squared. So 2, and remember 2a dA dt plus 2b dB dt equals 2c dc dt. And so I can plug in all these things, okay? So I know that A is, well, A and B stands for N and E, so I'll make A N. So A is 400 times the ADT, the NDT is 125 times 2. And I've got to calculate that using Pythagorean theorem. So 400 squared is 16. 1, 2, 3, 4 plus non-calculator, really? Oh, 300 squared is 9. 1, 2, 3, 4 equals c squared. So that's 250,000. Oh, they're so sneaky. Square root, c equals 250. Where is that? Wait. 250,000, 250. So 250 times 250, 154. 250 times 250. 25 times 25 is 25 times 25. Nope. That'd be 500. Yeah, 500. C equals 500. Okay. So C equals 500. dc dt. I don't know. This is crazy. I'm gonna go ahead and let y'all know right now. And so, oh my gosh. So 250 times 400. Okay. 250 times 400 is same as 225 times 4 plus 3 zeros, so that's 100 plus 3 zeros, 100,000. Okay, and then yeah, that's 250. Yeah, that and that made 250 times 400 is 100,000 plus 200 times 300, which is the same as 6 plus 4 zeros, 1, 2, 3, 4, equals 1,000 dc dt. Holy cow! 160,000 equals 1,000 dc dt. Alright, so that's dc dt equals 160 miles per hour. OMG. Man, that's rough. Okay. Alright, so moving on. Alright, 5. The twice I'm sure this is scaring you now. I'm sorry. The twice differentiable functions f and g are defined for all real numbers x. Values of f prime, and g prime of x for various values of x are given in the table above. Find the x coordinate of each relative minimum. So that's where x goes. F prime of x goes to relative minimum. It's going to go from positive to 0 to negative. No. Negative to 0 to positive, indicating that on the interval negative 2 to 3. Okay, so all these are negative 2 to 3 basically. So, okay, so we can assume, okay, so the derivative is negative from negative to 1 to 0, and then, alright, so the derivative is, each relative minimum. So it doesn't specify which ones, alright, so negative, so for f, it's negative 0 to positive right there, okay? So f prime, so f has a relative min at x equals 1. G basically has no relative minima. Okay, I JYA this by saying, okay, JYA by saying f prime of x goes from negative to positive at x equals 1. G prime of x never goes from negative to positive. Okay, B. Explain why there must be a value C between negative 1 and 1, such as f double prime of C equals 0. So let's look at f and let's look at negative 1 and 1. Okay. Well, that's basically, oh, sorry, you can't see. That's basically, so you see how f prime, okay, hold on. F prime of x was 0 right here and 0 right here. So at some point, f prime of x's slope had to basically be 0. Okay? So what it's saying is the derivative was 0, it went underneath the x-axis and came back up to 0. Well, that means that the double derivative is based off of this slope, right? So the double derivative would go from concave down to inflection point to concave up. The inflection point means the double derivative has to be 0. Well, we've got to JYA that, so basically, and you can use the mean value theorem because, as you can say, by the MVT, the average rate of change of f prime of x must equal the derivative of f prime of x on negative 1 to 1. What that means is that the slope, obviously based off of this table, the slope of the derivative is, when you connect these 2 points, is 0. So the double derivative must equal 0. So f double prime of x must equal 0 on negative 1 to 1 by the mean value theorem. And that might not make any sense. This isn't a hard AP exam. It's got a lot of weird stuff in it. The function h is defined by h of x equals natural log of f of x. Find h prime of 3. Show the computation to lead to your answer. So h of x equals natural log of f of x. We want to find h prime of 3. So let's take the derivative of h. Derivative of h prime of x would equal 1 over f of x, f prime of x. Okay, and we're going to find h prime of 3. It's a chain rule, y'all. It's a chain rule. No biggie. Okay, so 1 over f of x. F of 3, so it's f of 3, so f of 3 is 7. F prime of 3 is 1/2. Okay, h prime of 3 basically equals 1/14. Oh my gosh, easy. Oh, thank you. That was easy. Alright, so D, evaluate the integral from -2 to 3. What? That's one I come back to. But I'm going to plow through it. You know, I'm your Huckleberry. I'll do it. So basically, it's the F prime composed with G. Okay. Oh, this is basically a U substitution problem. And I know you probably wouldn't have guessed that in a million years, but if you write it out, it makes sense. Alright, see that? So, oh my gosh, this is so crazy. So basically, f prime of u du, right? Okay, so basically it equals to the derivative, this integrating the derivative, so it's going to cancel out. It's going to give you f. It's going to give you f of x. Actually, it's going to give you f of g of x, sorry. Because it's going to give you fu, sorry. And then, so that's f of g of x, right? And then, so, and now I've got to plug in -2 to 3, and then -2 to 3. So basically it's f of g of 3, take away f of g of 2. And basically you just got to plug it in the g first, okay? So if I plug it in the g first, so g of 3, what's g of 3? Let's look up here. G of 3 is, g of 3 is 1. So really that becomes f of 1. And then g of 2 is, where's 2? There is no 2. -2, I'm sorry. -2, so g of -2 is -1, so it's really f of -1. So we're doing f of 1 minus f of -1, so f of 1 is 2. And then, so f of -1 is 8. So 2 minus 8 is -6. Wow. Okay, so moving on. Slope fields, yay, this one should be okay, I hope. Let y equals f of x particular solution to differential equation with the initial condition f of 0 equals 1. The function f is defined for all real numbers. Portion of the slope field differential equation is given below. Sketch the solution curve through the point 0, 1. So 0, 1, it's going to following the leader, following the leader, and then it's going to go something. And then I guess it's going to, I should have came here a little bit and then go back up. And then kind of, yeah, something like that. There you go. Write an equation for line change of the solution curve at point A at the point 0, 1. Use the equation to approximate f of 0.2. Alright, well, we've got the point 0, 1. So we've got our x1 and our y1. So y minus y1 equals m times x minus x1. Alright, so y minus 1 equals m times x minus 0. So y minus 1 equals mx. We gotta find m, so we plug this into the derivative. The derivative is this. So dy dx equals 3 minus y cosine x. So 3 minus y, 3 minus 1. So dy dx equals 2 cosine times cosine of 0. Cosine of 0 is 1. Dy dx is 2 times 1, which is 2. So y minus 1 equals 2x, so y equals 2x plus 1. Okay? Now if we want to approximate f of 0.2, so we just plug in 0.2, y equals 2 times 0.2 plus 1, which is y equals 0.4 plus 1, which is y equals 1.4. And that's an approximation. Okay? And well, that's y equals 1.4, but we need to write our answer as an approximation, so it's basically f of 0.2 is approximately 1.4. Okay? Approximately. Oh, last one. Unless I skipped a question, I gotta make sure I did them all. Find y equals f of x particular solution. Oh yay, separation of variables. 3 minus y cosine x. 1 over 3 minus y dy equals cosine x dx. Be careful, this is u sub. U equals 3 minus y, du equals negative 1 d, du equals negative 1 dy. Okay, so there's no negative 1, so negative 1 du equals dy. So I'm going to put those back in with a negative 1 as a multiplying constant. The u replaces the entire bottom. The du's right here. Right, that's just going to be sine. Okay, so then that's obviously negative 1 natural log, the absolute value of 3 minus y. Okay, move them 1 over. Natural log 3 minus y, negative sine x plus c. Drop an e. 3 minus y equals e to the negative sine x plus c. Negative y equals e to the negative sine x plus c minus 3. Move the negative e to the negative sine x plus c plus 3. Okay. And then initial condition 0, 1. Sine of 0 is 0. Okay. So that just gives you c plus 3. And move that over negative 2 equals negative e to c. Natural log, natural log. Now remember, you can't take the negative natural log. Oh wait, well we can't natural log yet. We divide by negative 1. Okay, so 2 equals e to the c. Natural log of 2 equals c. Okay, and there I plug it back in, and I just leave it. So that's going to be y equals negative e to the negative sine x plus natural log 2, oh my gosh, plus 3. Let's see, that's number 6, number 5, number 4, and number 3, I think. Where's number 3? Yes. Alright, I'll send another video with a grading portion of this. You don't have to watch it. I'm sure you're probably interested on how whether or not I messed up. If you're not interested, that's fine, but I'd like to know whether I messed up, and you can too if you'd like. Peace out.